4.3 is all about right triangle trigonometry. So let's get straight into some of our identities. This first set, here in green, you've seen all of these. We know our basic sine, cosine, tangent with right triangles. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cotangent is opposite over adjacent. So that must mean that for cosecant, since it's reciprocal of sine, hypotenuse over opposite, secant would be hypotenuse over adjacent, cotangent would be adjacent over opposite. We've used all those with right triangles. We should be set there. A couple new ones. Tangent, if you think back to our unit circle, was y over x. Since we know that sine goes with the y and cosine goes with the x, it does make sense that tangent would be sine over cosine. And cotangent is therefore cosine over sine. And then this purple set is your Pythagorean identities. Sine squared plus cosine squared equals 1, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. You will need to know these. I can almost guarantee that the reciprocal identities and the quotient identities you will see and use so much that they will be ingrained into your head. Your Pythagorean identities, you should be close to seeing them so much that they're ingrained into your head, but if not, then make sure you've studied them and know what they are. Let's get into using them. So we have theta, which is an acute angle, and I know that sine of that angle is 0.6. I want to find the values of cosine and tangent using my other trig identities. So if I think back to my trig identities, the only one that involves both sine, since I know that, and cosine, since I want to find that, is this Pythagorean identity. So to find cosine, I'm going to use that Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. So with what I know that sine is 0.6. So sine squared of theta has now become 0.6 squared. Plus cosine squared of theta equals 1. 0.6 squared is actually 0.36. Subtracting that over, I'm going to get that cosine squared is 0.64. Taking the square root of that, I'm going to get that cosine is 0.8. For finding tangent, now that I know sine and cosine, I can go ahead and use that quotient identity where tangent is the same as the sine of theta divided by cosine of theta. So since I know that sine of theta is 0.6 and cosine of theta is 0.8, all I have to do is divide those, and I know that tangent is 0.75. So taking the values I give you and literally plugging them into the equations, as far as identifying which identity you're going to use, think about which trig function you already know and which trig function you're trying to find. Another thing we do is what's called verifying a problem or a trig identity. So it says use trig identities to transform one side of the equation into the other. So I'm going to change one side until it looks the exact same as the other side. I'm not flipping stuff from the left to the right like I would solve an equation, or right to left. I'm just messing with one side, and eventually it's going to be the same as the other. So when starting, first thing you should always do, of course, is write down the problem. And then you decide which is the more complicated side. More complicated side here is the left, so that's the side I'm going to mess with. One great step to take from there is to rewrite using sine and cosine, or in this case, I'm going to use my reciprocal identity, because instead of secant of theta, I can say 1 over cosine of theta. From there, my cosine of theta is canceled, so I'm simplifying. And all that's left on the left side is 1, all that's left on the right side is 1. Both sides of the equation are the exact same. That's how I know I'm done. That's called verifying. Another one, so this is B, same directions. Again, I write down the original equation. I've decided that the left side is clearly the one I need to work with. It's the most complicated. And here I see that I have one set binomial, one set of trig functions being multiplied to another binomial or set of trig functions. So I'm going to go ahead and multiply those out. And I'm going to FOIL, if you want to call it that, or use your distributive property. But I get secant squared theta minus secant theta tangent theta plus secant theta tangent theta minus tangent squared theta. So all I did was distribute, or FOIL, if you'd prefer to call it that. Simplifying that, those negative secant theta tangent theta and positive secant theta tangent theta, those cancel. So I end up actually just having secant squared theta minus tangent squared theta equals 1. So I've simplified to get there. For my fourth step, I'm going to use my Pythagorean identity to get me to 1 equals 1. Let me show you what I mean there. So since I have this Pythagorean identity that said 1 plus tangent squared is secant squared, I'm basically, in my head or on paper, instead of secant squared here, I'm going to have 1 plus tangent squared. So if I had 1 plus tangent squared minus tangent squared, that would just be 1. Whether you write that step in is up to you. I did list out the identity so you would know which one I was using them. Last thing with this section is making sure we can evaluate this on our calculator. So in order to put this into my calculator, I don't have a secant button, but I do have a cosine, so I'm going to rewrite it as 1 over cosine of theta, cosine of 5 degrees, 40 minutes, 12 seconds. Second thing, before I ever touch my calculator, type numbers or anything in, I need to check the mode of my calculator. Since this is 5 degrees, blah, 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 I'm in degree mode. From there, I'm going to type it in. So 1 divided by cosine. If my calculator doesn't open up the parentheses, I'll do it for it. For the 5 degrees, I can obviously type in 5. And then to get that degrees, remember you have to go second, apps, and then option 1. And then for the 40 minutes, I can just type in 40, obviously. To get my minutes, it's second, apps, 2. For my seconds, I'm going to type in my 12. Now the seconds is not under that angle menu, so it's just alpha plus. And then close your parentheses off. Hit enter. I'm getting about 1.0049. I do realize that's more than 1. In previous lessons, we've talked about that your domain or your answer for these should be between -1 and 1. That was for sine and cosine. This is secant. So it does not need to be between 1 and -1. So this is totally okay.